Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping out. Please note that this is the fifth video, guys, of me answering the November 2023 Physical Science Paper 1. If it's the first video you come across, please note that there are four videos before this one whereby I tackle the first four questions. You can download the question paper, answer it with me, and then see if there are differences with what you've written and what I've written. Are you together? So if you don't understand the things I'm saying, please do say it on the comment section. I'll try by all means to make you understand or help you understand rather. Okay. Learners conduct an experiment to determine how the initial kinetic energy given to a trolley affects the distance of the trolley or affects the distance the trolley moves on a rough horizontal surface. A learner pushes a trolley um, a learner pushes a trolley of unknown mass until it reaches point A with the kinetic energy EA. Okay, the horizontal distance traveled by the trolley before it comes to rest is then measured. See the diagram below. Okay, so in this case, guys, we have a trolley which is just standing still here at this point. Are you together? It will be then pushed just to give it the initial kinetic energy. It will then come to a stop. Why? Because it is going on a rough horizontal surface, and there is no force applied just to make sure that it continues moving to the right. So it moves from point A until this point. Let's call this point B. Are you together? Between point A and B, there's only one force that is acting on the trolley. That force is a frictional force. Are you together? And whenever I say there's only one force acting on the trolley, I'm talking about the horizontal forces. Are you together? I'm not mentioning the vertical forces because I know that they will cancel one another. Are you together? So if ever I'm asked to draw a free body diagram of the trolley as it moves from A to B, it will be like this. I'll have my gravitational force because yes, my trolley is in the universe, so it will experience the weight. I also have the normal force. My trolley is on top is on top of a surface, so it does have a normal force because normal force is a contact force, right? And then I'll have the frictional force that opposes the motion of the trolley, kinetic friction. So this will be the free body diagram if ever I'm asked to do it. Okay, and then we are told that the experiment is repeated with the n with can't excuse me, guys. The experiment is repeated with the trolley moving on the same rough horizontal surface, but with different initial kinetic energies at point A. Okay, the results obtained are shown in the graph below. Now, okay, we have the kinetic energy on the x-axis and the displacement traveled. Okay, but they did say that the experiment was to determine how initial kinetic energy given to a trolley affects the displacement, which simply means that the kinetic energy of a trolley will be the one that will be physically manipulated, which simply means the initial kinetic energy is the independent variable, and the displacement that the trolley will travel will depend on the initial kinetic energy. So my kinetic energy will be the independent variable. This will be the dependent variable. Okay. Okay, let's work. We have okay. We are told to ignore the rotational effects of the wheels of the trolley. Okay, question 5.1. Draw a labeled free body diagram showing all the forces acting on the trolley during its motion passing point A. This will be the free body diagram. Please note that the free body diagram will be like this. I'll have normal force here, F normal, F gravity or weight, and then the kinetic friction, which will be opposing my motion, right? Okay. Then 5.2, we are being asked to name the independent variable. Remember that independent variable is the initial kinetic energy, because according to the investigation, the learners are trying to determine the distance traveled if they keep on changing the initial kinetic energy of the trolley. So kinetic energy is the independent variable, right? Okay. So now I'm supposed to state the work energy theorem in words. It simply states that the net work done on an object is equal to the object's change in kinetic energy. Okay, and then 5.4, we are being asked to calculate the mass of the trolley if the coefficient of kinetic friction between the wheels of the trolley and the rough horizontal surface is 0.18. Okay, I know that the net work done on an object is equal to the object's change in kinetic energy. All right, together. Okay, the change in kinetic energy, I can simply say EK final minus EK initial, right? So this will be equal to the work net. All right, together. So, but how do I find the work net? Work net is simply F net delta X cos theta. All right, together. So, in this case, guys, the change in kinetic energy, if I can take these two kinetic energies, that means the 6 joules will be the final kinetic energy, and the 0 joules will be my initial kinetic energy. All right, together. So I'll simply have 6 minus 0 joules. All right, together. And then for my F net, the only force that is being applied here is no, not being applied. The only horizontal force that is active in this case is frictional force. Are you together? And remember that frictional force always opposes motion. Are you together? So I'm expecting to have a negative kinetic friction. The displacement traveled, let me write this here. I'm expecting to have a negative kinetic friction. The displacement traveled is given, right? I'll have 6 minus 0. The displacement traveled is 1.5, because if I choose these 2 points, that means the distance traveled I need to use is 1.5 as well. Yeah? Okay, but remember that, guys, cos theta, the frictional force is opposing motion, so my theta will be 180 degrees. Are you together? So this thing simply means that whenever I'll simply have 1.5 Fk on the left hand side is equal to 6. Then Fk will be equal to 4 newtons whenever I divide both sides by 1.5, right? So I now know that my kinetic friction is 4 newtons. Let me continue on the other side. Let me use blue. Okay, remember that there's a formula for me to calculate the kinetic friction. Is mu k multiplied by the normal force. Are you together? Mu k, the normal force cancels with the weight, so it simply means that the normal force is equal to the weight. So mu k multiplied by mg is equal to my frictional force. But I do know the value of the kinetic friction, and I also know my coefficient. Are you together? Let me write underneath here. I do know the frictional force. I do know the coefficient of friction 0.18. I want to find out the mass of the trolley, and the gravity is 9.8. So therefore my mass will be 4 divided by 0.18 multiplied by 9.8. I'll simply get 2.27 kilograms. That's how, guys, should have tackled that question. Just stay tuned, guys. The sixth video is on its way. Please don't forget to subscribe, guys, and like if you are happy, and please share as much as you can. Help us to reach many learners who might need help. Okay, thank you, guys. Bye bye.